Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. In the last video, we have summarized all the steps for nodal analysis to solve AC circuit. If we follow the steps here, we need to draw the diagram in phasor form. If we look at the current source here, it is equal to tan sine 2t, which is in cosine form, tan cosine. We can draw to convert this. This is cosine, this is sine. And to convert from sine to cosine, you can minus 90 degree. So 2t minus 90 degree. Or in phasor form, this is in tan is the amplitude and the degree is negative 90 degree ampere. We can write down the value in this phasor form diagram, tan 90 degree. And then next we need to find the impedance of each. For resistor, we have the real part, which is 2 here, and then 4. And for impedance of L is equal to J. What is the omega? Omega is equal to 2 radian per second. Coming from where? Coming from here. So J omega 2 and L is equal to 2, which is equal to J 4 ohms. And for impedance of capacitor is equal to minus J over 2 into 0.2, which is equal to negative J 2.5 ohms. We can write down all these values in the circuit. So the capacitor is equal to minus J 2.5 ohms and impedance of inductor is equal to J 4. And dependence power supply here is equal to 3 Vs, the capital Vs with bar. This is in terms of phasor form. Next, in step number 3, we need to draw the reference point, which is at the nodes with the most branches, which is at the bottom. And then we need to name the nodes here, the other nodes that we have. So if you look at this, Vx here is equal to over here it is voltage drop at 2 ohms of Vx. Then we can name the nodes here equal to Vx bar. And then this node 3 Vx bar. And this node is equal to V2. Or any name that you like. Step number 4 is to draw the current direction. This is up to you, but you need to observe the passive sign convention of each power entering passive elements or leaving it. Step number 5 is to identify the supernode. Supernode is when you have a voltage source, either this is independent or dependent power supply. As long as this is a voltage source in between two unknown nodes, then this is a supernode. Then you need to draw the boundary of that. But in our circuit here, we do have a voltage source, but this voltage source is attached to a reference point, which is a known value. But the other side, we have a 3 Vs. That one is also a known value. Since we don't have any supernode, then we do not need to apply KCL or QBL at the supernode. Steps number 6, you need to build up KCL at the unknown nodes. KCL at Vx is equal to current entering, which is tan negative 90 degree, equal to current leaving, which is Vx minus 0 divided by 2 plus Vx minus V2. This one you just follow the passive sign convention. Since the current is from left to right, then we have a positive here and negative the other side. So Vx minus V2 divided by negative J 2.5. Simplify this equation and rearrange it. You will get this equation number 1. KCL at is equal to Vx minus V2. This is current entering, divided by minus J 2.5 equal to V2 minus 3 Vx divided by 4 plus V2 minus 0 divided by J4. If you simplify this equation, you will get 0.75 plus J 0.4 into Vs plus 0.25 plus J 0.15 imaginary side into V2 equal to 0. So we will continue our circuit here in the next video. Thank you. This one's supposed to be a negative. Okay. And the rest I think okay. Then we rearrange back. Vx is equal to 0.25 plus J 0.15 into V2. You will get this answer all in 0.343 of 2.891. Better to have at least 3 decimal point V2. Okay, and then this is the equation number 2. Then we substitute into equation number 1 here. V2 is equal to 25.857. Oops, sorry. V2 is equal to 27. Equal to 33.02 negative 32.87 degree. Or we write down in terms of V2 with respect to t equal to 33.02. Remember, this is in cosine and omega is 2t minus 32.87. But since the given question is in sine, you need to convert it back to sine. So 33.02 sine to t minus 32.87 plus 90 degrees. So you have a plus 57.13 degree. Okay, and this is in volt. Okay, so we will continue with the next slide. The previous number 2 equations, we have to substitute the V2 equal to 33.02 with negative 32.87 degree, and this is equal to 9.81 minus J 5.659. Everything is in, yeah, you can get the answer using calculator and make sure your calculator is set into complex form and degree. Okay, so what is the answer in with respect to t? 11.33. Oh, this is equal to 11.33 with negative 29.98 degree in both. So 11.33 cosine of 2t minus 29.98 degree, or we put it as a 11.33. We do this one. From cosine we want to change to sine because the question is in sine, so you need to plus 90 degree here. So this is in sine to t plus 60 degree. Okay, in both. So yeah, so that's all for this video. Thank you.